We are live. So in this video, what I want to do is talk about while loops. And basically a loop is something that repeats a block of code, a fixed or arbitrary number of times depending on different conditions. So let me just give you an example. It's probably the best way to show it. So maybe I'm going to start with I equals 0. And then I'm going to type while I is less than or equal to 10. I want to print the value I, and let's make it pretty. Um, and so I'll print D, percentage D, and then I'll put in the I variable. And then what I'm going to do is increment I by 1. And the best way to do this is to set I is equal to I plus 1, right? So initially I is going to be 0 when that block of code's written, and then we're going to increment it by 1 value. This is such a common bit of code that Python actually has a shorthand, which is I is plus equal to 1. And that's going to increment it by the value 1. So both of these two statements, this one and this one, are identical, but you often will see this one much more often because it just makes life a little bit easier. So I'm going to just comment this out. And so what's going to happen is it's going to say I is equal to 0. And then while means while this statement is true, run this block of code right here. So until I is equal to 10, this block of code is going to run. So I run it, and I'm going to get 1, 2, 3, 4, 5, all the way to 10. If I went to 20, if I went to 15, it's going to continue to the 15 value. Just come back to 10 so it doesn't go off my screen. I can also increment by 2. I don't have to increment by 1. And now it's going to go 0, 2, 4, 6, 8, 10 here. And you can do kind of anything. We can also do calculations. So maybe I want to look at I, and let's do percentage D. So D is the symbol for an integer. You could also use G. That's just as good. I've covered that already. So I could do I comma I squared. And now I run it, and I'm going to have the I value here, and then the I squared value all over here. To prevent this shifting, we can add some space. So we can maybe say we want at least 4 spaces given to the numbers. This is different than after the decimal, and now it kind of shifts everything over. I could even do something fancy like I is equal to this value, and then I could say I shift squared is equal to that. And then we're going to have kind of our answers coming along. And so that's kind of a common statement we're going to do when you want to run through a loop. And typically what you're going to do is iterate some value, and then you're going to check a condition on that value. So very common bit of code that you'll probably use a fair amount. One thing to recognize, maybe I made a typo here. So plus equal means that I'm going to add, I'm basically setting I is equal to I plus 2, but I could also do minus. So I is equal to I minus 2. And if I run this code, this is one of the problems with while loops, is what you're going to find out is it's just going to run forever, right? Because this condition, I being less than 10, is always going to be true because we're going 0, 2, 4, 6, and it's just going to run. And if I keep on going down here, eventually we'll probably get an overflow. Whenever you see the star, this means this block of code is running, and this loop is going to run forever, so I don't want that to happen, so I'm just going to hit the break here. I can fix this up again, and I get back my code. So let's just do the simple one. Let me clean this up a little bit, and let's just increment by 1. So one of the common tasks we might want to do is maybe we want to sum numbers. Maybe we want to sum I squared from 0 to 10 and kind of get a sum here. In a couple lectures later, I'll show you how to do this much more efficiently, kind of using list comprehension in Python. But what I can do is I can define a variable, and so maybe it's my sum. I'm not going to call it sum because sum's a reserved word, or it's a built-in function, and I don't want to overwrite that function. And the way to think about this is I think about this as like a bank account. And so what I'm going to do is just say my sum is equal to my sum plus, say, if we want to sum I squared, and then maybe at the bottom we can print our my sum variable. And what we'll get is kind of the sum, which in this case will be 506, right? Because each time we're adding the I squared value to the my sum. Actually, I think I did this. Actually, this one's going to be actually incorrect because I have to do it before I increment. So probably a better way to do it, because really what I'm doing here by putting it below the 1 is basically I'm summing from 1 to 11. And let me come back up here. Sorry about the mistake. And if I do it before I increment, so here we have I is equal to 0, I sum it. And now when I run it, I'm going to get 385, which will be the sum. So a very common task with doing while loops. Another trick we can do with a while loop is, sometimes I do this in my code. I don't know why, but I prefer it. But we can introduce a break in the code. So I could just say while true, right? So while true means it's always going to run. So maybe I'm going to print. Let me actually come back up here and grab that bit of code. And I can come over here. And I'm going to have the I is equal to +1. And what's going to happen here is because it's true, it's always going to run this block of code forever because this is always true. But what I can do is say, if I is bigger than 10, I can put the break statement. And what's going to happen is whenever I hit this break statement, it's going to break me out of this loop, right? So the loop's running infinitely, but if a certain condition is met, it's going to break out. And when I run this, I get the same code. I get from 0 to 10 and the I squared from 0 to 100, because when I gets to 10, it comes up to, when I is 10, it's going to run this block because basically this is false, print it out, then I gets incremented to 11. And when I is incremented to 11, it comes up here. 11 is bigger than 10, and so this is true, and that means you're going to put a break, and that's going to break us out. We could even put a print statement here, and we're saying, breaking, see when this occurs. And here we're having our breaking statement, and we can say breaking at I equal to %g, and I can put %I, so we can actually even see we're breaking at I is equal to 11 to kind of get a sense of when this break statement occurs. So while loops are used a lot, they're nice for when we want to iterate, when we're trying to iteratively solve an equation and we want to solve it up to a certain tolerance. And so the tolerance will be specified in kind of the expression up here. And so that means it'll keep on iterating until some condition is true. However, you often want to have kind of a statement that, you don't want to run the while loop. Often you have a sense ahead of the time how, many times you're going to run the while loop. And so you might have a counter that'll tell you how many times you run that while loop. And maybe if it gets above, say, 1,000, you're going to say, hey, something's not working right, and you might want to break out. And so often when I do kind of while loops, I'll put an if statement where I'll say, I only want to run this, say, 50,000 times or even 100 times. And actually, in a lot of algorithms we'll cover later, there's an option where you can basically change the maximum number of iterations that'll run the loops in the code or the iterations in an iterative code. Sometimes the default value isn't high enough to solve problems and you have to increase it. But you can think about that as just a while loop where we're basically breaking out if the number of iterations kind of exceeds a certain number. So with that, I'll stop. Again, if you have questions, put them in the comment section. And the next video will be discussing lists. And once we get lists, we can actually do another way of doing loops, which are for loops, which typically iterate on lists. All right, bye.